Space has always fascinated me. It is a reality mankind is yet to explore. For hundreds of years, we lived off speculations and beliefs. In the latter half of the 20th century, rockets were finally developed that were powerful enough to overcome the force of gravity to reach orbitable velocities, paving the way for space exploration to become a reality. If you want to pave the way for future videos on the future of space technology, please consider leaving a like and subscribe. Currently, only 4% of all viewers are subscribed. It's free, and you can change your mind at any time. On October 4th, 1957, the Soviets launched the first artificial satellite, Sputnik 1, into space. 4 years later, on April 12, 1961, Russian Lieutenant Yuri Gagarin became the first human to orbit Earth in Vostok 1. His flight lasted 108 minutes, and Gagarin reached an altitude of 327 kilometers. The first U.S. satellite, Explorer 1, went into orbit on January 31, 1958. Alan Shepard became the first American to fly into space in 1961, an unheard of accomplishment beforehand. On February 20, 1962, John Glenn's historic flight made him the first American to orbit the Earth. Landing a man on the moon and returning him safely to Earth within a decade was a national goal set by John F. Kennedy in 1961. An arbitrary goal that might not do as much as, say, a satellite or putting a man in space, but a goal nonetheless. On July 20th, 1969, astronaut Neil Armstrong took one giant leap for mankind as he stepped onto the lunar surface. 6 Apollo missions were made to explore the moon between 1969 and 1972. Since that first step, the revolution in space exploration rapidly increased. We started to know things that were only dreamt of before. Human access was far just beyond the moon. The idea of colonizing or the possibility of taking trips around the solar system in our spaceships for anyone willing to take the chance was in discussion everywhere. NASA has been a prominent name in space exploration, and most people believe they are the only organization in the world that managed to escape orbit and return safely in the world and in history. But today things are changing. Entrepreneurs like Elon Musk have made groundbreaking achievements in the field of space exploration and were founded in 2002 by Elon Musk with the goal of reducing space transportation costs to enable the colonization of Mars. SpaceX manufactures the Falcon 9 and the Falcon Heavy launch vehicles, which include several rocket engines, Dragon cargo, and they also crew the spacecraft and Starlink satellites. SpaceX's achievement include the first privately funded liquid propellant rocket to reach orbit, first private company to successfully launch, orbit, and recover a vehicle, the first private company to send a spacecraft to the International Space Station. The list keeps going. The first vertical takeoff and vertical propulsive landing for an orbital rocket, and the first reuse of an orbital rocket. Not to mention, the first private company to send astronauts to orbit and to the International Space Station. This is no small feat. If we can commercialize space, we not only have the supplies and resources of NASA, but also the supplies and resources of capitalism, which, despite some of its flaws, is very efficient at stuff like this. SpaceX has flown and reflown the Falcon 9 series of rockets over 100 times. But the struggle of colonizing other planets and the most popular suggestion, Mars, has always been something associated with the future of mankind. That Earth will become so overpopulated with humans that decent survival will become a commodity reserved for not everybody. It could become something to compensate for the lack of area to accommodate more people and species that are responsible for keeping the ecosystem going, all of which is non-existent on Mars as of now. All we know today is that scientists and rovers sent to Mars by NASA found traces of water on the planet, which is not the best evidence that human life or any life can survive on the planet for that matter, at least not Homo sapiens. Let's suppose we find a way to get into a rocket ship and leave for Mars. What then? How will we be able to produce energy? It is practically impossible to harvest the energy required to run another planet from scratch. And to answer this question, let's ask Dyson spheres, a hypothetical megastructure that completely engulfs a star and captures a large percentage of its power output without affecting too much of the planets that rely on it. The concept is a thought experiment that attempts to explain how a spacefaring civilization would meet its energy requirements once these requirements exceed what can be generated from the home planet's resources. Only a tiny fraction of the star's energy emissions reach the surface of any orbiting planet, such as Earth. building structures encircling a star would enable a civilization to harvest more energy. However, because of the extreme amount of resources that is required to build a Dyson sphere, some say that it is impossible. In fact, we would probably have to disassemble an entire planet. But this will have an astronomical cost on building, and if we become able to realize the idea of harvesting energy and using it for our benefit, is there a way feasible enough to send masses to other heavenly bodies? To answer this question, let us walk around Skyhooks. Not the musical band, but a space transportation concept that will help make spaceflight affordable to everybody. When used as part of a combination launch system, it will make the building of a spacefaring civilization possible on a commercial basis. There are two kinds of skyhooks, the rotating skyhook and a non-rotating skyhook. A non-rotating skyhook is a much shorter version of the Earth's surface to geostationary orbit space elevator that does not reach down to the surface of the Earth. It is much lighter in mass, can be affordably built with existing material and technology, and in its most current form, is cost competitive with what is thought to be realistically achievable using a space elevator, assuming materials strong enough to build a space elevator ever become available, which they are currently. Think of it as a momentum exchange device that captures the energy of returning spacecraft and uses it to propel spacecraft away from Earth. It just stores it. The idea of a non-rotating skyhook evolved from the idea of an orbital tower, which was first proposed by Constantine back in 1895. The orbital tower consists of a really tall tower that goes from the surface of the Earth all the way to geostationary orbit. Its purpose has to provide an economical way of getting to orbit so that the human race could start building a spacefaring civilization. The reason for wanting to build a spacefaring civilization was to avoid the projected collapse of our civilization at some time in the near future due to overpopulation. We still do not have a concrete solution. On Mars, the atmospheric pressure is around 0.6% of Earth's. Any liquid on the surface would quickly evaporate or freeze. One of the challenges of terraforming the red planet is to increase its atmospheric pressure. The Martian polar caps, minerals, and soil could all provide sources of carbon dioxide and water to thicken the atmosphere. But a new study in the journal Natural Astronomy, a peer-reviewed journal, finds that processing all resources available on the planet would only increase the pressure to about 7% that of Earth's, far short of what we need. Changing its environment to be more Earth-like in a way that would allow terrestrial life to survive without the need for life support systems, proposed releasing greenhouse gases from a variety of sources on the planet to thicken the atmosphere and increase the temperature to the point where liquid water is stable on the surface. That alone is not enough, because the magnetosphere also needs to be created before we begin to think about an atmosphere. According to a new analysis, the most accessible source is carbon dioxide in the polar ice caps. It could be vaporized by spreading dust on it to absorb more solar radiation, or the old-fashioned Texan way, by using explosives. However, vaporizing the ice cap would only contribute enough carbon dioxide to double the Martian pressure to a measly 1.2% of Earth's. There is a very good chance that we might be looking in the wrong direction. In 2015, review concluded that the exoplanets Kepler 621, Kepler 186f, and Kepler 442b were all great, likely contenders for being potentially habitable. All of these distances are far beyond the lifespan of a person if they were to be going at 1 light year per year. This means that if we were able to travel at the speed of light and retain the optimal physical form, the new Earth might not be a vacation destination. It can take another couple hundred of centuries before we come up with the technology. Even if we manage to come up with it, it will be a matter of choice made by the ancestors of generations to come. We might be able to communicate with our faraway neighbors, but traveling to New Earth in a lifetime will be impossible, considering the average lifespan of a human is not likely to be 500 years anywhere in the near future, even with current life-prolonging technology. With that, what are your thoughts on the newest take of space exploration? Will we ever be able to achieve these goals? Or is it a lost cause? Share your thoughts in the comments below. If you would like to watch more videos like this, consider subscribing to the channel and like this video. Thank you all for watching, and I'll see you in the next one.